Lesson 18, Triangle Congruence. The objectives are to apply side, 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 and side, angle, side to construct triangles and solve problems, and to prove triangles congruent by using side, 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 and side, angle, side theorems. Vocabulary are triangle rigidity and included angle. There's a new property to use for congruence, and this is the property of triangle rigidity. It gives you a shortcut for proving two triangles congruent. It states that if the side lengths of a triangle are given, the triangle can only have one shape. For example, you only need to know that two triangles have three pairs of congruent corresponding sides. This can be expressed as the following postulate: the side, side, side congruence. If three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. Remember, adjacent triangles share a side, so you can apply the reflexive property to get a pair of congruent parts. Let's look at an example. Use side, side, side to explain why triangle ABC is congruent to triangle DBC. Here's our picture. You can see that we have AC and CD are congruent, AB and BD are congruent. It is given that AC is congruent to DC and that AB is congruent to DB. By the reflexive property of congruence, BC is congruent to itself. Therefore, triangle ABC is congruent to triangle DBC by the side, side, side postulate. An included angle is formed by two adjacent sides of a polygon. B is the included angle between sides AB and BC. It can also be shown that only two pairs of congruent corresponding sides are needed to prove the congruence of two triangles if the included angles are also congruent. Postulate 442, the side angle side congruence postulate, states if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. We see here that AC is congruent to DE, that AB is congruent to EF, and that angle A and angle E are congruent. The conclusion then is ABC is congruent to EFD. Make sure that you know that the letters SAS are written in that order, because the congruent angles must be between pairs of congruent corresponding sides. The diagram shows part of the support structure for a tower. Use side angle side congruence to explain why triangle XYZ is congruent to triangle VWZ. If we look at our picture, we have XZ and VZ are congruent, and WZ and YZ are congruent. So we have two sides. And if we look at the angles at Z, they are vertical angles. So we know those are also congruent. And we prove it this way. It is given that XZ is congruent to BZ, and that YZ is congruent to WZ. By the vertical angles theorem, angle XZY is congruent to angle VZW. Therefore, the two triangles are congruent by side angle side congruence postulate. The side angle side postulate guarantees that if you are given the lengths of two sides and the measure of the included angles, you can construct one and only one triangle. For example, we want to show that the triangles are congruent for the given value of the variable. So triangle MNO is congruent to triangle PQR when x equals 5. PQ, x plus 2, and if we plug in 5, we get 7. And PQ should be congruent to MN, which it is, if x is 5. QR is x, which is 5. So QR and NO are congruent when x is 5. And for PR, it should be congruent to MO. And we get 3 times 5, which is 15, minus 9 gives us 6. So those two would be congruent. If we can match the segments, then we say that they are congruent by side-side-side congruence postulate. Let's look at another set of triangles. When y equals 4, we want to show that these are congruent. So we plug 4 in for each of the sides, and we have ST is 11, TU is 7, and the measure of angle T is 92 degrees. Since the corresponding sides and the angles are congruent, then STU is congruent to VWX by side angle side congruence postulate. Let's look at another example and write a proof. If we're given that BC is parallel to AD and BC and AD are congruent, we want to prove that triangle ABD is congruent to triangle CDB. So first of all, we are told that they are parallel lines, segments, so that's given. And we know that angle CBD is congruent to angle ABD, and that's the alternate interior angles theorem. BC is congruent to AD, that's given. BD is congruent to itself by the reflexive property of congruence. So triangle ABD and triangle CDB are congruent, and that's the side angle side, steps 3, 2, and 4. Now I want you to try. For next class, complete the U-Try problems and bring them to class. We'll check your answers during class, and bring your notes to class and be ready for the mid-chapter quiz.